Okay, in this video we will look at the area between graphs, and the easiest way to do it generically is to look at a specific example. So we have to find the area that's bound by y equals to 2x, x squared minus 2 and y equals to negative x. So let's just have an idea what these graphs will look like. So we know that x squared is a parent function, and it's going to be translated by negative 2, so it's going to look like that, going through negative 2 on the y-axis, and the line y equals to negative x goes straight through my origin. So really what we're trying to look at, or we're trying to determine, is we're trying to determine this area here. So if you will remember, if we have a definite integral, we have to find it between a specific place. So in that value place would be where it is on your x-axis. So we will need to find our x-intercepts here, or our x values for which this is true. So we're going to do this by putting these equations equal to each other. So we have negative x equals to x squared minus 2. So we can see we have a quadratic function here that we can solve. So this is quite an easy one. We can just see it factorizes in 2 and 1 plus 2 minus 1. So then we know if we solve it, it gives us the x equals to negative 2. So this value here is negative 2, and x equals to 1. So we are going to integrate the function from negative 2 to 1. And the function that we're going to integrate is this, right? The top part of your function minus this part, the bottom part. So it's basically the highest one minus the lowest one, minus, and then this function is x squared minus 2, and all of this we are integrating in terms of x. Okay, so that is what my integral and my integrand looks like. So I'm going to do that on the next page. So the easiest thing to do is for us to just get rid of all these brackets that's inside my integrand. So I have minus x squared minus x plus 2. So all of this is being integrated in terms of x. So we have minus a third x to the power 3 minus a half x squared plus 2x, and that is all between my boundary conditions. For this is all negative 2 to 1. So I'm going to substitute, and then I'm going to just substitute my values like that, and then basically if we simplify it, it gives us 9 over 2. So just to recap what you do if you do the integration. So if you have any curve, you're going to say, so let's say it's so that y1 is at the top, so something like that, and your y2 is below it, like let's say that, you're going to say it's the integral from a to b in terms of your x value. So from a to b, your top curve or your top function right? And top and mean, I'm talking in terms of your y value, minus your the one that's lying lower in terms of your y, and then you're going to integrate it in terms of x, because remember these y's is going to be expressed in terms of x, so you're going to integrate in terms of x.